Hi guys, welcome to the third video of structural and foundation analysis of building. In this video, I will explain, analyze, design and detailing of mat foundation while using safe software. By using this problem statement, in this problem statement there are 16 columns and having distance of 16 meter along x-axis and y-axis. The safe bearing capacity of soil is 300 kN per meter square. Allowable settlement is equal to 1 cm. So subgrade modulus is equivalent to safe bearing capacity by allowable settlement, which is equivalent to 300 kN per meter square by 1 cm, which is equivalent to 3 into 10 power 4 kN per meter cube. Here column strip width is equivalent to, as we know, it should be least among L1 or 0.25 L2. So here both L1 and L2 are 18 centimeter. So least one 0.25 into 18 is equal to 4.5 meter. But we will consider strip width as 4 meter. Here there are different columns and having different dimensions. The dimension of columns varying from 500 cross 500 and 600 cross 600 with varying dead load and live load. The materials used here are HYSD 500 and M40 grade concrete. So we will open the safe software. Here click on file menu, new model. In new model, first we have to choose the design code. So as we know, we are using IS 456 2000. Here unit is here already set as metric. If it is not, we can change here, also modify this and select here metric default. Okay, now click on modify show. Here minimum cover, as we know, as per IS 456, minimum cover for foundation should be 50 mm. So we have to write 50 mm, and as per this, for this mat foundation, the performance bar size is 22 mm. So click on OK. Here for mat foundation there is no option for initial model for mat foundation, so we have to use grid only option. Here as we know, there are it is 18 meter length and breadth, so we will keep spacing of grid spacing 1 meter. So we have to write in x direction 19 grid lines and also in y direction 19 meter 19 grid lines. Also this grid spacing is 1 meter along x-axis and along y-axis also 1 meter. So click on OK. So our grid format, as it is like a graph sheet, has been displayed in our desktop view. So after this we have to define property. So go to the define menu, click on properties. Here there are by default 3 materials which we don't need, so we need to add different materials. I will click on add new material. Here write it name as M40, as we are using M40. Here material type as concrete. We know that unit weight per unit volume is equivalent to, for concrete is 25 kN per meter cube, and coefficient of thermal expansion is 0.0000055, and concrete cube strength will be 40 Newton per mm square. So click on OK. Again go to the add new material. Now we will write name as HYSD 500, as we are using HYSD 500. So here material as rebar. Also choose this edit this material weight as 500 is minimum tensile stress and also maximum tensile stress 500 Newton per mm square. So click on new. As we saw here, HYG 500 and M40 grade concrete has been added, so we will click on OK. Again go to the define menu, go to slab properties. Here we need to add new property. Click on add new property, write its name as anything slab 1 or footing. We can write here footing. Choose slab material as M40 and choose thickness as 1200 mm. Click on OK. So our footing has been displayed. Click on OK. Again, now to define the columns, again go to define menu here, then go to column properties. Here add new columns. As we know, there are two types of columns. We are using 500 cross 500 mm and 600 cross 600 mm. So we write first name column 500 cross 500. Here choose material as M30 and dimensions as 500 cross 500. So click OK. Again add new material, add new property. This time write name as column 600 cross 600. Material same M40 and dimension is 600 cross 600. Click on OK. So our two column properties have been added. So click on OK. Now again go to the define menu, go to the style subgrade properties. Here we can add new property, or also we can modify the same soil 1 property. So we will modify this, modify show property. Here as per our design submodule subgrade modulus is 3 into 10 power 4. So we will write 3e plus 4. So click on OK. So it has been modified. Now we will check the load patterns and load cases. So again go to define menu, then load patterns. Here load pattern dead and live load are here. So click on OK. Again go to define menu, load cases. Here same dead and live cases having linear static, as we are using linear static only. So this is OK. Click on OK. Again now we have to give the load combination. So again go to the define menu, select here load combinations. So there are no load combinations, we have to add the load combinations. So we will click on add new combination, write it as its name same as combination 1. So for dead load scale factor is 1.5. Again for live load same scale factor is 1.5. So here choose design selection as strength ultimate. Click on OK. So combination 1 has been added. Again go to the add new combination, write name as combination 2. Here for select first dead load. For dead load scale factor is 1. Also for live load scale factor is 1. So here choose design selection as service normal, service initial and service long time. Click on OK. So our both combinations have been added. So click on OK. Now we will draw the slab area. So go to the draw option. Here draw slab areas. Here we have to check whether the property is footing or not. Here it is footing, so it is OK. So we will draw, we will start from one point. We will start from this point. So from this point like this, this, and to complete this I have to click where from I have started. So our slab slab has been we have draw our slab. So now click on escape to cut this one. Now as we have to draw the columns, before drawing the columns we have to extend this slab, as our column will be drawn at the end point. So we have to increase our slab. So we will select this. Here we will confirm that our slab has been selected. So after selecting this, go to the edit menu. Here in edit menu, edit areas. Here expand or shrink areas. So we will expand it by 2 meters from all sides. So we will write 2000 mm. So click on OK. So our this footing has been extended. So after this we have to draw now columns. So for this, go to the draw options. Here click on draw columns. Here in draw columns, first we have to write property below, we have to write it as none. Property above, first write 500 cross 500, and height below keep it as 0, and height above keep it as 2 meter. After this we will draw the column likewise. First column, C1 column will be here, then there are 6 meter distance, so second will be here, then accordingly third will be at here, and fourth one, C4 it will be here, then C5 will be at a distance of 6 meter from this, so it will be here, then C7 and C8, this is of another type, 600 cross 600, so we will not put their column, so we will put another column, C8 here, then C9 will be here, also C10 and C11 are of different size dimensions, so we will not put there, we will put this one here. Again C13 will be here, 13, 14, 15 and 16. Now go to the column properties. Here choose column as 600 cross 600, height above column to 2 meter only. So after this draw these four columns, C5, C6, C9, C10 and C11. So after this close this. Now we have drawn the columns. After completing these columns, we have to draw the strips. So here go to the draw menu, go to design, here go to the draw menu, here we have to go to the draw menu, here we have to draw the strips, draw design strips. Here first we have to strip layer should be A, and as we have the strip width we have 4 meters, so we have to write 4 meter for everyone. So after this we will draw strip. These strips we should pass through the columns. Again now we have to choose the strip layer B, and strip width is same for that also, so we will draw these strips now. After this we have to cut this. After drawing this we can click on set display options. Here we can highlight this design strip objects. Labels also show width and show citation. After this we can see that our this stripe design has been shown in this model. For further working on this, we will untick this again, so we will untick these labels show width and show citations. Okay, so now we can work on this. Now we will give the properties. For that, first we will click on the footing. After clicking on footing, we can see here our footing has been selecting. After this go to the assign menu, here slab data, then go to the assign menu, here slab data, then properties. Here in properties we have to select footing, then modify show properties. Here footing M30 and it is okay, so we have to click OK. So our footing has been added, and same for columns, it has should be also added. So we will click on right click of any column, in right click of any column, we can change this rebar material. Here we have to choose the rebar material as HYSD 500. HYSD 500 has been added. Okay. Again, we can click on right click on this footing. In footing, here rebar material has been added as HYSD 500 to chalk. After this, we have to select every strip of this every strip. Click on every strip right here and choose this rebar material for every strip as HYSD 500. We cannot choose them combinedly, we have to select them separately. For every single strip we have to select it separately and then giving separately the rebar material as HYSD 500. So after for every strip we have completed using HYSD rebar. Now we have to assign the loads. So to assign the loads for the columns, we have to choose the columns. So for this we have to select click on the center of the column. As for this problem, the load for the external columns is different and for inner 4 columns this is different. So I will select the exterior columns first, second, third, 4, 5, 6, 7 is not, then 8th one, 9th one, 10th, 11th not, 12th one, then 13, 14, 15 and 16. As there are 12 exterior columns, we can see here 12 points have been selected. After this selecting, I have to go to the assign. Here in assign, go to load data, here point loads. Here as it is dead load, here for dead load we have to write in z in gravity z direction. So the dead load here is 12,200 kilonewton. So here the size of load punching shear for these outside column is 500 in x dimension also and in y direction also 500. So click on OK. Again I have to select these columns. So to select these columns, I will go to the select option and get previous selections. So these 12 columns have been selected. After this again go to assign menu, go to load, point loads, here write as dead load, live load. Here live load is 1000 kilonewton. So it is 1000 kilonewton. Click on punching shear area is same, so click on OK. So dead load has been dead load and live level has been assigned for this external column. Now we will select the interior columns. 1, 2, 3, 4. As we can see here 4 columns have been selected. So go to assign load data, point loads. Here dead load first. Dead load is 1350 for this. Here patching value is 600 cross 600. So click on OK. Again we have to select these. So for this, select get previous selection, 4.7 selected. Go to assign load data. Here point loads. Here we have to write the live load, and write the live load here is 1100. Punching is OK. So live load has been assigned to this. So after this I will now analyze this. So go to the run menu. Here run analyze. So before it will analyze, we have to save it. I will write it name as mat foundation. Mat foundation final. Save. As it has been analyzed, and it gives us this value 46.5 modulus. So after this, go to run analyze and design. So after this, go to display, see show punching shear design. As here for every one punching shear value is less than 1, so our design is okay. So we don't have any problem with the design, as it is okay. Again we can go to the display menu. Here show strip forces. In show strip forces, we can choose the load cases, live, dead, whatsoever load combinations as we have given here too. Then we can see for movement, axial force, shear force, torsion. For layer A and layer B we can see that. Like see here, I can select this movement. Here the load case is dead, so I can see apply. So for this forces are like, why is this? I can select here live. For that I have to apply. For this little bit changes are there. I can see also the shear forces. For shear forces, see it is different. Accordingly I can see for torsion. So for every torsion, movement, shear force and axial force for live load, and for combinations, if I choose combination 1, it will show different. For this, for if I choose combination 2, it will show different. So accordingly we can see these strips. Again we can go to the display menu. In display menu I have to click show slab forces stresses. In slab forces stresses, in display I have to go to show slab design. In show slab design I have to mark impose minimum reinforcing. After this I have to apply. After applying, close. So it will show this. In layer A also we can go for layer B. Again go to the display menu. In display menu we can see show crack widths. So in this show crack width, for every load case and for every this load combination, it will show the load cracks. It will show for bottom face also and top face also. For example, here bottom face is selected. For dead load I can see apply. Here you can see for this different color showing different values. Also I can write here live load also. So for apply it will little bit change. Also I can write here slab top face. For slab top face also it will show some different. As you we can see in display, it is showing showing different. So accordingly we can seeing this. Now after this we can go for detailing. So go to the run. Here click on run detailing. Here we have to mark these three as already it is marked. So click on OK. So it has been the software has detailed. After detailing we have to expand this detailing draw detailing components. In this also expand slab views. In slab views we have to double click on rebar table. See here, the rebar table has been displayed in menu, in which it is showing the bar mark, dia, shape, cut length, and total length of that member, and numbers how much we have to use. Also I can click on rebar schedule. Similarly, also in bill quantities. See, bill quantities, it is showing the number of bars we are being used, and total length of that bars, and total weight of that bars. Also in we can expand this individual slab view, their slab view. Here we can see for different top view rebar plan, we can see rebar plan, we can see bottom rebar plan. Also for bars we can see section 1, we can see section 2. Accordingly we can see profile for reinforcement level, layer A, and similarly for layer B. Accordingly we can see these different properties of the material. By this way I have completing the design, analysis, and detailing of the reinforcement. Thank you for watching this video.